to talk about this firewall use case with the inline acceleration. So I'm Mohammad Abdul Awal. So the talk we are going to present, I just categorize in a three brief section. So first, I'm going to give status update. What is the so far status of this recipe, and then I'll go a bit little deep dive on this, how we did it, and just to show you like how it works so far, and then finally we can have some discussion on this. Uh, so to start with, so we have upstreamed this recipe to the IPDK website. I think as you probably already aware, but I also just put it here to show, just as a reminder, like we upstream it to the IPDK.io as a recipe. Maybe we can have a look um, on this as well. So this is the website where you can see if you haven't seen it. So this is as a part of the recipes where we have already some other recipes there. This is part of this inline function acceleration. So it's a firewall function acceleration. So there are some details. You can have a look at the bottom of this IPDK, this the recipe page. You can see there is a link as well, where we have all the scripts and some example P4 file and others are already upstreamed. So this is in the IPDK repo as well. So those are part of this. This is IPDK repo here. So we have example folder, we have P4, and we have some patches like TPDK and BPP patches, how we implemented this acceleration, and also some scripts like a build P4 OVS or cleanup. So just to tell you that this is a POC version, and we did validate it against this specific SHA in the repo, like, and also a specific the version of these. So our idea is to give it to you in your hand, and then we want to see how it goes. What are the feedback we receive from the community? How we can help to solve your problems. Um, so this is pretty much described in this in detail, like how we go through this recipe, how we build, how we run the P4OVS, how we create the ports, and how we load the VMs, how we run the VMs, like the BPP application or other package and application, pretty much all we have covered in this recipe. So now let's go back to my slide deck again here. So here again, I showed like what are the things we have. So this is the script, and we have the firewall.p4, like which is a sample P4 file. And also we have this uh, the patches. One is for the DPDK patch, like we enabled using RT flow, the API, DPDK RT flow API, and the BPP flow, how it used that, how it invokes that RT flow from the BPP to accelerate those flows. So a bit more detail here. We are going in this, like this is showing like overall the solution recipe for the inline acceleration. So this is on top of basically the IPDK IIS framework that so we have this P4 OVS, and this P4 OVS is capable of having a specific pipeline underneath with a specific target, and it is managed through this table driven the API, table API. So basically we can have a pipeline underneath. It could be any pipeline we want. In our case, it would be a firewall.p4, and it could be compiled for different targets. It could be NIC, programmable NIC switch, or DPDK itself, like in a CPU itself, or it could be BBF. So these are any of all those targets. And on top of this is the application sits on the top, right? So when it communicates through the P4 OVS to the using to like a P4 runtime interface or OpenConfig interface. So application which is supposed to have those functionality, how to talk to them, to that P4 OVS, and then to program a specific rule or to create ports, remove ports, those kind of functionalities. So this overall framework does like enables like a third-party ecosystem as well for the in the networking domain. If we feel free to stop me or ask me question if you have anything on here. So let's continue. So in this solution recipe, after, so this is an example scenario, right? Like, so if you have a, firewall use case, if it is a next gen firewall, we want to use as a firewall apply, software. What are the scenarios? There could be so several functionalities there, and we can choose what to actually the accelerate underneath in the pipeline. So here I'm showing you an example, like there could be a functionality like the IP field forwarding or the ACL rule as well. There could be inspection, content inspection, like IPS or the more application identification as well. It could be NAT or routing. Those kind of all functionalities could be accelerated underlying. So in our example here, in this whole the POC, we only attacked or tackled this problem, the ACL functionality here. So this when we want to offload or accelerate this application use case or a scenario, it could be based on different, like a customer's application requirement, right? Like some might want to offload like a long-lived flows, or somebody who said like some of those specific flow probably don't need to check every now and then. So based on different criteria, we could offload. So that's why we only here I'm showing only this SCL functionality. So in this, you can see like the light blue path is the slow path, and this dark blue path direct line is the fast path. Like let's say if we have accelerated the whole all functionalities, this is what it would look like. Now a bit more technically detailed here, and I will go through a demo as well if my system is up and running. I mean, working properly functionally. So the demo, I'll show you that this is in that host we have. So at the orange box here and like here you can see, or yellow box, you can see the P4 OVS, the infrastructure is running, and the P4 OVS itself, it underlying, it has a firewall.p4. So we have a firewall.p4, we compiled it, and we programmed this with the P4 OVS. So there is underlying, it would be firewall functionalities, mainly here the ACL functionality. And we have two VMs. So basically, to attach to those VMs, we create several ports, like a vhost ports here. You can see those, the blue lines are those vhost ports. And then we do have those VMs. So one of the VM we used as a traffic generator, another is the VPP as a like a firewall application here. So when the traffic comes, so you can see that to the pipeline from this traffic generator, this orange, this line. So it goes all the way to the host, like this is an exception traffic. So it goes all the way host and go back to that traffic generator through the pipeline again. This is the scenario we set up. Now, if we enable this offloading or acceleration through the pipeline, then instead of going through all the packets going through the VPP, it will just go directly from the pipeline back to the traffic generator. So this is the scenario I'm going to show you. So, and again, I said that we use this firewall.p4. So when we compile the firewall.p4, so basically we have, it generates those firewall.p4 info file. And now we use that p4 info file inside this RT flow, the shim layer, like in the VART.io PMD. So basically that's how it knows that what are the tables there, what are the flows, what type of the matching, is it exact matching or is it a LPM or those kind of things. It is aware of those flows tables, and then the application will use that run to offload those flows in the underlying pipeline. So let's go, and if I show you here, so I have an skin running. Um, so it would be what I'm going to do is running a script. So basically this is script, what are all those things are already in that IPDK website is already described maybe, but I would like to show you this very quick uh, code, maybe if it is not. So here, what very simple, I'm cleaning up. So I have, if there is an existing OVS running or anything, I'm just cleaning up, and then I'm going to create some ports. So before that, I'm going to run the OVS, of course. So run OVS script, and then so this even this run OVS script also in the IPDK website. So I'm just creating, oops, uh, creating some ports, and then I am creating this pipeline using the firewall pipeline, which is in with underneath the P4OVS, and then I'm launching two VMs and show you that what exactly they're doing. So let's go back here. So I'm running this script and see what it does. So it is cleaning up all those if it's existing running and checking there are some other ports that we have. So okay, so I just ran it. So I think it need to cleaning up those pipelines again because there were some existing rules there, so it was failing. So I just run it again. Probably didn't clean it up. Okay, so yeah, so that's what it ran. You can see that this OVS vSwitch D running successfully. It is created. It has created 4 vhost interface, and then it is launching the VM. So it's and after launching, it will try to log into the VM. Now just wait for like say 10-15 seconds. So I have 2 windows there. So one of the window will be here. I'm logging, and another window I'm trying to log into the other window. So okay, so this one is already up. So this let's see. So this VM I'll be using as a BPP. So let's say if I and the other screen I'll be using as a packet gen. So let's say if I run VPP here, so I have a script. Um, so that is also described in the IPDK website. So if I run it VPP here, and so if I show you interface, like I have 2 ports created, which are the vhost through the vhost port, and there are currently no traffic is basically going through. Now, what I first I want to show that without offload. So I here in this demo, I have just a command like rtflow wrapper disable. So I just have a command here. So I just disable this, and let's see again show interface. Uh, some of those traffic. So here the packet gen is not running. So those are probably some broadcast traffic coming from. Now, if I run the packet gen setup from the other VM. So you can see that here the traffic, it is sending like a TXing after like 500,000 packets or like 700K packets. And at the same time, it is also receiving all those packets, right? So let's go back to the VPP and see what is the status of. So I can see that the traffic count is increasing. It is going through this VPP and those rules, and there's the ACL rules are being going through this. So there is a when we run VPP, there is a configuration file as well, which is showing like what are the rules to create those ACL. Actually, those are also given in the IPDK website. Maybe I could give you a quick show here. Like if you go to that IPDK website in that examples, and here the VPP firewall configuration. So these are the rules actually I'm running underneath, right? So there's a based on this traffic, these are the rules I'm running underneath. So okay, let's go back here. Now I'm still traffic is still running. So what I'm going to do, I'm going to stop traffic, and I'll just run this VPP again so that it is so we have no traffic coming. Now, if I, and I didn't disable this RT flow wrap. So if I do this again, it starts 0. So you can see the traffic now it's pumped to 1.5 million, is sending and receiving. And oh, here also is showing a log that it programmed some of those flows in the underlying the pipeline, the firewall.pipeline. It is showing only one of them. Actually, it programmed 2 flows. One is that setting the direction, like after this packet is with this LPM, like which direction to go the traffic, and second one is the matching the ACL. Actually, that's one is not showing in that log, but let's show in that interface, and I can see that the traffic actually is not incrementing in the BPP side because it's already offloaded, and all are managed in the underlying P4OVS side. And you can see the traffic is still going on, and they're in that in the network. So that's pretty much a quick overview of this demo I wanted to show you. And let's go back here. So what else? Yeah, that's pretty much it from my side. We can now, the question is like when we created this, it was for the P4OVS, and now we could do this for extend it for the other platform like IPU or any other switch as well. It is possible to do those kind of things. So I would like to hear the feedback from you, or any questions, any kind of discussion we'd like to trigger from here. That's the whole idea. Thank you very much. Do you have any questions or anything for me? Or
Yes, hello, it's Thomas Monjalon. Do you
hi,
hear me?
Thomas. Yeah.
Okay. Yeah, I have a few questions. First of all, I did not understand very well what is running on the host and what is on the device. And by the way, what is the device?
So everything is host here. In that right now I'm running it. So in that the VM also running in the host, and the P4OVS also running in the host, right? So it's a so basically we have 2 VMs running inside the host, and also the P4OVS also running on the host. We don't have any specific programmable hardware here
Okay.
because yeah.
So this model of running everything on the host is part of the IPDK scope? Is part of
This
the
is also
goal of
part
the
of the,
project?
yes, this is also part of this IPDK. Yeah.
Okay. But if I understand well, in IPDK, it's okay to run everything on the host, but there is also a goal to run some things, to offload things to the device, to the programmable device. Am I
Correct.
right? Correct.
Yes.
And this OVS, P4 OVS, are you able to run it on some device?
Yeah, it is possible, right? So we do have some work going on, and it is possible to run those inside. Like a device means, like as an example, let's say in the IPU, we have this. It is possible to run those in those IPU as well.
What do you say when you say IPU? Excuse me, I'm not sure to
Uh,
understand. Do you mean something with an FPGA, or what is exactly an IPU?
it is it's a Mount Evan, right? The device which is Intel announced some days back. Yes, that's it's
What
not
what what
with
what,
the.
what is it?
This is a smart NIC with the infrastructure processing unit. Basically, this comes with this the flexible pipeline, and also some ARM cores with that.
There are some ARM cores, okay, and there is no FPGA.
There is no FPGA. No. So
Okay.
it's a
Yeah, if
basically
you
it's a
look at
ASIC. Yeah,
if you
yeah.
go to the IPDK website under documentation,
Uh-huh.
there's a section on the targets that we're testing right now. So there's a Mount Evans target. There's an FPGA IPU target. Marvell has IPDK running on some of their Octeon DPUs.
Okay.
And the Topino switch. So there are several different targets that we're testing with. What we do for releasing of software is that we test everything with the software target, and we are trying to figure out a clean way to be able to, run and test IPDK on different devices, understanding that all those devices usually have their own proprietary software that's not open source. So it's very easy for us to run everything with the software model like we just showed here, and hopefully coming soon. We're trying to work with the different target vendors to find a good way for developers to be able to also run IPDK and OPI on these different targets. There's
Okay.
lots of different ones.
In the case of Octeon, it means that something of Marvel is helping to test everything on Octeon?
Yes.
Or do you manage by yourself?
Marvel, they did a demo of IPDK a couple months ago. So yeah, it involves a lot of participation from the vendor to be able to sort of kind of get this running together. But we use the software model as a baseline to make it easier to run.
Okay, I get it. Okay, now I have question about, but maybe someone else have more question. But I have question about the software.
Yeah.
Yeah, do you want to take it? So I know that P4 OVS is part of IPDK. But I know also that there are some discussion to merge it inside upstream OVS. I would like to know what is the status currently.
Oh, that's a great question. Next week, I think it's Wednesday at 9, we're going to do a P4 OVS update. We're making a bunch of changes to hopefully minimize the amount of OVS changes that will be required to add P4. So shameless plug. We're going to go into that in detail with Namrata next week.
Okay, so it will be an update in IPDK.
Yeah.
And are you continuing the discussion with upstream OVS community?
Yes. So
and how it seems? Do you have a hope to fully merge P4 OVS?
Yes, that's definitely the goal. We don't want to continue sort of what we have now is sort of a pretty active fork, and we want to merge that back. And so we made all these changes in response to their feedback.
Okay, so let's imagine P4 OVS is fully merged in OVS.
Mm-hmm.
So the question which comes to my mind is, so what is remaining in the IPDK project if we remove P4 OVS, because now it's part of OVS? Okay, let's imagine.
Yeah.
So I understand maybe there are some control plane part, or please can you explain how the things are split?
So for example, this demo today, Abdul showed how you can use P4 OVS as a control plane framework for different applications. So here, our use case is a firewall, is packet processing, allowing you to offload some amount of that packet processing goodness to the application running on the host. We have a different recipe for storage. We have different recipes for IPsec, for we're working in OPI on telemetry. So the P4 OVS happens to be a very large piece of the code base in IPDK, but it's just one component for all the different recipes that we've been putting together. And if you go back to, well, I guess if you go back to the website, there's a little icon that shows all the different use cases and the different targets, and so that's primarily what we're trying to do is enable all of these different use cases on lots of different targets, so that if you could take your use case like the firewall and be able to bring it to IPDK and OPI and make it easier for you to be able to support all these different types of targets than what you have today, which is to take your application, take your firewall, crack open the SDK and start on one target, and then maybe go to a second one, and you're pretty much done after that. So we're trying to make it easier for these application developers to be able to run their applications on different devices, and conversely, if you're a device vendor, to be able to bring your device and have it run all sorts of different applications without too much effort.
Okay, sorry if I make you repeat, but I just want to make things very clear. When I go to the GitHub of IPDK, I see two main repositories. One is OVS and the other one is IPDK. So let's imagine OVS is a temporary fork. So let's imagine in the future we don't have it. All the content of the IPDK project is inside the IPDK repository, right?
That's right.
And there it's all in the build directory. And here
Right.
I can see different applications. There is a firewall, networking eBPF, storage. That's my understanding. Okay, and all these applications are running on top of P4OVS?
Storage doesn't use P4OVS, Firewall does. So P4OVS is used in the sort of the networking related projects. We have a couple other projects that are coming down and in development. But yeah, ideally, all of the projects that are forks will be re-upstreamed back into their main projects, and IPDK will more or less be a mechanism for validation and for sort of building all of these different components together in a consistent way. That is that's the end goal of what IPDK as a repo would represent.
And then where the application will be? Where it will be hosted?
The applications would be hosted by their respective recipe. So if it's storage, we're using SPDK. If it's
for firewall, where it is?
The firewall would be separate, so you'd be bringing your own firewall application. This example here is just doing the enabling, so a firewall can connect over RT flow to your infrastructure.
Okay.
Yeah. So if let's say someone did bring a firewall application and they wanted to integrate it, they could put code to integrate that firewall into IPDK. So that's definitely an option. So what we're doing is developing some of the enabling for those applications to make it easier for them to adopt these different targets.
Okay. Okay, so it's an enabler to connect to the infrastructure, if to sum it up.
Yes.
Okay. I'm also, at the same time, I'm trying to understand how IPDK is going to integrate into OPI. Because there are some temporary content, there are some things which are examples like proof of concept, and you imagine that in IPDK you would like to have some kind of libraries. Is it possible?
Yeah, so IPDK does rely on libraries for the SDK for the targets, for example, for the devices. And we don't have any SDK code in the IPDK, but we have to have an interface to be able to connect in a consistent way to all of those different SDK libraries. So inside of OPI, we've been advocating to have a consistent library interface for all those different types of from all the different vendors. And we do have a meeting tomorrow in OPI to talk about the OPI and IPDK sort of integration path. So we hope to get more clarity other than what we presented at the when we joined Linux Foundation, which is that IPDK is a sub-project of OPI. And so once OPI starts to have more structure, releases and more definition in of itself, I think it'll fall out. What's the right way to define the relationship between the two. So we'll talk more about that in the OPI call. And I also too, the question that you brought up is how does OPI and IPDK relate to the different applications? How do they relate to a firewall? How would they relate to a storage backend? Those are separate code bases, but but how you interact with those applications. You know, in IPDK, we've defined different RPCs so that they can be, you know, sort of separate applications that interact with IPDK. So OPI, we could take the same approach or modify it. That'll depend on, you know, the decisions that we make in the Open APIs forum.
Okay, thank you. I think I have no more question.
Is there any other question?
I had a question for you, Abdul. Can you just give some color as to the next steps on this on the firewall acceleration? So what you intend to do next?
So yeah, we had we have a plan for this. So yeah, there was some work going on as well. So I just give you like some backup slide. I have one of the slide would be like if you want to do this for the Mount Avon, right? So basically where we will be running. So Thomas, your question as well as you asked. So this is the like underneath the Mount Avon IPU, and in the host on the we have some application firewall running. So here the OVS, P4 OVS or IPDK would be running on those ARM core, and then we could do this program and target it as a those the firewall.p4, but it would be different target. It's not that P4 TPDK target is that Mount Avon target. So it would be part of the FXP pipeline at the bottom. So basically, that would be the next would be the idea. Yeah. Done.
Cool. Yeah, that makes sense.
Thanks.
What is CPF lib?
It's a control plane function. It's a part of the IPDK.
I don't see it in the
No, sorry,
repository.
not the IPDK. Sorry.
Yeah.
Part of it's a the IPU programmable. It's a library comes through that.
Yeah.
So
There's a library in the IPU SDK.
IPU
It's
SDK.
part of it.
what,
Part of the SDK. Yeah.
are we able to download this SDK, or it's proprietary coming with the hardware?
Proprietary coming with the hardware. Yeah.
Okay.
We have a separate effort to try to come up with a kernel driver for these types of devices, but that's sort of separate from the IPU SDK, which is proprietary. Great. If there's no other questions.